All right, as you're finishing that up, we're going to start on 265. Find the area and the side length of each square. What is the area of square A?
9.
Each side is 3. Area of B? 2. So what's each side length?
2. No. Wait, how did you get 2?
Half of each square.
Half, 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 half. See?
Ten.
10 is correct. These two make 1, and then the middle ones all make 1. So side length? Now the point of this is you're going to start to see numbers that aren't perfect. There's only so many of those to go around. Irrational numbers means you're going to have to deal with a square root. Something that is not a perfect square. You're not going to see square root of 36 every problem or square root of 81 every problem. Okay, so being able to deal with numbers that will be decimals as well. And you're going to see that from example 2. Solve each equation. Be sure to use the plus or minus notation when appropriate. So I'm going to add 13 to both sides. So what would make that equation true?
1.
And?
Negative 1.
Question 2, what would make that one true? 6. 6 minus 6 squared is the only thing that would give you 0. See? Nothing. Even if you move the 9 over, nothing squared is going to give you negative 9. That is not possible. Question 4. What squared is 18? Yeah, so there's one that doesn't come out perfect.
Does the negative sign need to be in front of the thing?
Yes.
Okay.
Next one, I'm going to subtract 1. It's going to be the exact same problem, except it's square root of 17. Again, doesn't come out nice. And the last one's just kind of a combination. It's going to be the square root of 18, and then whatever it is, you're going to have to subtract 1 to it. Combination of 4 and 5 put together. So the point is, you're not going to see all perfect examples because there's only so many of those to go around. So we're going to solve these by factoring. Can also complete the square, your total choice. Doesn't specify which one. It says for each one, find the exact solution. So that means that it's going to have a square root. You can't use a decimal. So typing that into decimals will give you decimal. That will not qualify. If you do want to give both, you certainly can, like they did up here. So question number 1. X squared plus 4x plus 1. How would you like to solve that? You can complete the square. You can try to factor. Factors of 1 that add up to 4. You're going to see that's not going to get us very far. So let's complete the square, which is why it's nice to have that as an option. I'm going to move that 1 over. And then what number would I have to put on both sides? 4 divided by 2 squared. Now what? Square root of both sides. Square root of 3, again, I don't know that, so I'm just going to put the square root of 3. And I got one last step. Subtract 2. So I got negative 2 plus the square root of 3. And I got negative 2 minus square root of 3. Those would be my exact answers. If you'd want a decimal equivalent, now you could type it into a calculator and get a decimal. Okay, let's do number 2. At least set it up for you. X squared minus 10x, I'm going to move that 18 over. Make it negative 18. Why don't you try to complete the square? Take that middle term and divide by 2 squared. All right, 10 divided by 2. 5. And square it to get the blanks. So there's the equation. Square root of both sides. And? Again, the only thing difference on these is it's not going to give you a perfect number here because square root of 7 we don't know. So I got to solve this one. I got to add 5. This one I got to add 5 as well. If you would want a decimal equivalent, 7.648. 5 minus square root of 7, 2.354. All right, question 3.
When are we gonna be able to factor it? Like, how do you know?
You can always try to factor. Then you gotta find something else. Which is why you have the other options available. Both of those you wouldn't be able to factor. You can't come up with factors of 18 that add up to 10. 1 and 18, no. 2 and 9, no. 3 and 6, no.
How many factors of 10?
Nope, it's always the factors of the last number. Question 3. Move the 1/4 over. Five divided by 2? Just gonna leave it as 5 over 2 squared. So 5 over 2 times 5 over 2. Jackson? 5 times 5? 5 times 5? 2 times 2? So that's what goes in the blank. 25 minus 1 would be 24 over 4. Which you could simplify just to 6. 24 divided by 4 is 6. Square root of both sides. X plus 5 over 2 equals square root of 6. X plus 5 over 2 equals negative square root of 6. Again, doesn't come out nice. How do I get rid of the 5 over 2? I got to subtract it. And those would be my 2 zeros. All right, I'm going to move the 14 over 9. Over. 8 over 3 divided by 2. Or times a half. It'll be 8 over 6. Or 4/3. I suppose I could reduce that right away. 8 over 6 squared. 64 over 36. Thinking we should reduce it. Change my mind to 4 over 3 squared, please. Four times 4, 3 times 3. 4 times 4, 3 times 3. And the reason I wanted to do that is so I don't have to mess with getting a common denominator over here. Now they're both a 9. 6 minus 14 is 2 ninths. All right, next step. Square root.
So are we keeping it 8, 6 in the square?
I'll change it. Doesn't matter though. Square root of 2 over 9. Negative square root of 2 over 9. Subtract 4/3. The book actually leaves it as this. We actually know the square root of 9 is 3, so you could change it like I did in the first one. Doesn't really matter. All right, let's take a look at the homework. First one is solving just like we started off doing. 2 is matching. Could do one of those if you want. A through E, anything look difficult there? No? Okay. 3, I think, is self-explanatory. All right, 4. 4 wants you to do what we did today in class and then verify it, graphing it. So let's do one of those together. Want to do the first one or second one? First. Again, you cannot come up with factors of 8 that add up to 10. That's why factoring doesn't work. It's not going to be a nice number. So I'm moving the 8 over. 10 divided by 2. 5. Squared. Negative 8 plus 25,
18 or 17.
17. Square root of both sides. X plus 5 equals square root of 17, and x plus 5 equals square root 17 with a negative out front. Subtract 5. Subtract 5. Type that in and see if we get the same when you can do it on decimals. Negative 5 plus square root of 17.
We have to do exact.
Negative 0.877. And negative 5 minus the square root of 17. Should get about negative 9.123. Okay, type that into Desmos just to verify that those are your zeros. What's that?
Can we not leave it as negative 5 plus square root of 17?
You can. It says find exact. Anytime it says exact, it needs to be those. Then find the approximate by graphing, which when you put it in Desmos, you should get those. That's what I want you to check. Type this equation into Desmos, make sure you get that. We got it. Goodness, you guys are have summer brains already, or what? Camera's running up there. You guys are supposed to be just typing this in. Just do it myself. All right, so here it is typed in. X squared plus 10x plus 8. Here are your decimal equivalents. Negative 0.887, negative 9.123. That's what we got. So you know you did it right. Again, Desmos is only going to give you this. That is not exact. Those are rounded. If it says exact, you need to square root. 5, 6, 7, 8 are all reviews. Any questions, let me know.